हेलो स्टूडेंट्स, आज हम लोग डिस्कस करने वाले हैं इलेक्ट्रोस्टैटिक्स। ये ट्वेल्थ का फिजिक्स का मोस्ट इम्पॉर्टेंट सेक्शन में से एक है और ये ऑलमोस्ट 8 मार्क्स कंसिडर करता है इन सीबीएसई बोर्ड। इलेक्ट्रोस्टैटिक्स, इसमें हम लोग डिस्कस करेंगे स्पेशली इलेक्ट्रिक फील्ड। और कौन कौन से टॉपिक आज हम लोग डिस्कस करेंगे वो हैं: नंबर 1 इलेक्ट्रिक फील्ड, नंबर 2 इलेक्ट्रिक फील्ड इंटेंसिटी और इलेक्ट्रिक फील्ड स्ट्रेंथ, number 3 electric field intensity due to point charge, number 4 superposition principle, number 5 electric field lines और electric line of force। इसके अंदर हम लोग डिस्कस करेंगे इलेक्ट्रिक फील्ड लाइंस ड्यू टू पॉइंट चार्ज, ड्यू टू डाइपोल, ड्यू टू इक्वल एंड लाइक चार्जेस, ड्यू टू यूनिफॉर्म फील्ड। Number 6 properties of electric line of force, electric dipole, electric field intensity due to an electric dipole, torque on electric dipole. Number 10 work done on an electric dipole. Let us begin with electric field. Electric field is a region of space around a charge or a system of charges within which other charged particles experience electrostatic force. Theoretically, electric field extend up to infinite, but practically it is limited to a certain distance. Electric field strength or electric field intensity. Electric field strength at a point in an electric field is the electrostatic force per unit positive charge acting on a vanishingly small positive test charge placed at a point. Let us explain with an example. Let us take a Q positive charge and in its vicinity Q positive test charge. Here we are observing that test charge is experiencing a force which is outward, and due to a negative charge the test charge is experiencing a force which is towards the charge. In the both cases test charge experience force, but due to positive charge it is outward and due to negative charge it is inward. So the direction of electric field depends upon the nature of source charge. Mathematically, electric field is equal to force per unit charge limit delta Q tends to 0, or electric field is force per unit charge. For more convenient mathematical form, electric field E is equal to 1 upon 4 pi epsilon naught Q upon R square, R cap. The test charge is considered to be vanishingly small because its presence should not alter the configuration of charge or charges, and thus the electric field which is intended to be measured. Note: number 1, since Q0 is taken positive, the direction of electric field E is along the direction of electrostatic force F. Electrostatic force on negatively charged particle will be opposite to the direction of electric field. Electric field is a vector quantity whose magnitude and direction uniquely determined at every point in the field. The SI unit of electric field is Newton per Coulomb. Electric field due to a point charge. Let us take a three-dimensional space in which a test positive charge or simply positive charge is placed at origin. Let us take a point P xyz at which a test positive charge Q0 is placed. Then it will experience a force that is outward. Hence, force extended on Q0 by Q is F is equal to 1 upon 4 pi epsilon naught Q1 Q2 or Q Q0 by R square R cap. This is according to Coulomb's law. Or F is equal to 1 upon 4 pi epsilon naught Q Q0 upon R cube R vector. Electric field strength is E is equal to F upon Q0. Therefore, electric field is E is equal to 1 upon 4 pi epsilon naught Q upon R cube R vector. Or electric field E is equal to 1 upon 4 pi epsilon naught Q upon R square R cap. If we compare the strength of electric field with the distance, then it is inversely proportional to R square. So we can say that as we increase the distance, the electric field decreases. Electric field in terms of coordinates is given by E is equal to 1 upon 4 pi epsilon naught Q xi cap plus yj cap plus zk cap upon x square plus y square plus z square under root 3 by 2. Superposition principle. The electrostatic force experienced by a charge due to other charges is the vector sum of electrostatic force due to these other charges as if they are existing individually. Let us take an example. As in figure, there are many charges around a given charge. Then we can say that the total force acting on a given charge is the vector sum of all. Here we can say that the total force on charge 1 is F12 plus F13 plus F14 plus F15. It means total force on charge 1 due to charge 2, charge 3, charge 4 and charge 5. In this way we can write all the sum of forces in mathematical form. Note, the interaction must be on the charge which is studied due to other charges. The charge on which the influence due to other charge is to be found as assumed to be floating charge and other charge are rigid. Electric line of force. An electric line of force is an imaginary straight or curved path along which unit positive charge is supposed to move when free to do so in an electric field. Electric line of force do not physically exist, but they represents real situation. Basically, electric line of force is used to explain electric field and phenomena associated with that. Electric field due to electric line of force due to a point charge. Here, for a positive charge, it is outward, and for a negative charge, it is inward. Electric line of force due to pair of equal and unlike charges or dipole is let us take a point P and draw a tangent at P. Then it will give the direction of electric field at P. Electric line of force contract lengthwise or represent attraction between two unlike charges. Electric line of force due to pair of equal and like charges. Let us take 2 points where Q plus and Q plus charges are placed. Here is the electric line of force due to two similar charges. The point N is known as null point, where the probability of finding the electric line of force is 0. Electric line of force due to uniform field. It starts from positive N and moves to the negative. Property of electric line of force. Number 1. Electric line of force are imaginary lines. A unit positive charge placed in electric field tends to flow a path along the field lines it is in free to do so. The electric field of force emanate from positive charge to terminate on negative charge. The tangent to electric line of force at a given point gives the direction of electric field at that point. Two electric line of force ever crosses each other. If they do so, there is two electric fields present in that point. That is almost impossible. Electric line of force are closer or crowded. It represents strong electric field. In figure first, it shows strong electric field, and in second figure it shows less denser and it is weak electric field. Electric line of force are perpendicular to the surface of positive or negatively charged body. Electric line of force contract lengthwise to represent attraction between two unlike charges. Electric line of force exert lateral pressure to represent repulsion between two like charges. The number of lines per unit cross section are perpendicular to the field lines is directly proportional to the magnitude of intensity of electric field in that region. Electric field lines or force do not pass through a conductor. Hence, the interior of the conductor is free from the influence of electric field. This is important line. That is why it is safer to sit inside a car in thunderstorm days. For a solid conductor, there is no electric field inside it. This is known as electrostatic shielding. Electric dipole. Sorry. Electric dipole is a pair of equal and opposite charge separated by a very small distance. The electric field produced by dipole is known as dipole field. Electric dipole moment is a vector quantity used to measure the strength of an electric dipole. P is equal to Q into 2L, where 2L is the length of dipole and P is strength of dipole moment. The magnitude of electric dipole moment is the product of magnitude of either charge and the distance between the two charges. The direction is from negative to positive. The SI unit of electric dipole moment is coulomb meter. Note, an ideal dipole is the dipole in which charge becomes larger and larger and the separation becomes smaller and smaller. Electric field intensity due to electric dipole. At a point on axial line. Axial line means a line which is joining its axis. Let us take a dipole in which the length of dipole is 2L, and from its midpoint let us take a point P along its axis, which is distance at x. Then total electric field at point P is given by the vector sum of electric field due to negative charge at P and positive charge at P. That is, EP is equal to 1 upon 4 pi epsilon naught Q upon x minus L का whole square minus Q upon x plus L whole square. Or electric field due to dipole at axial point is 1 upon 4 pi epsilon naught 2px upon x square minus L square whole square. Special case, if L is very small, smaller than x, then P is equal to, then electric field is equal to 2p by 1 upon 4 pi epsilon naught x cube. At point on equatorial line. Equatorial line means perpendicular to the axial line from its midpoint. Let us take a dipole in which Q minus and Q plus is placed at A and B of length 2L and a distance y from its center O. Let us take a point Q where charge Q is placed. Then electric field due to positive charge is outward and electric field due to negative charge is inward, and the vector sum of is given by the electric field due to dipole at equatorial line. For special case, if L is very less than y, then electric field due to dipole at equatorial point is equal to P upon 1 upon 4 pi epsilon naught y cube. torque on electric dipole in an uniform electric field. The force of magnitude PE acts opposite to the each, and hence each force acting on the dipole due to external uniform electric field is zero. So there is no translatory motion of dipole. However, the forces are along different lines of action and constitute a couple. Hence, the dipole will rotate and experience a torque. Torque is equal to electric force into perpendicular distance, or T is equal to QE 2L sin theta. Mathematically, torque is equal to PE sin theta, or torque vector is equal to P vector cross E vector. Direction of torque is perpendicular to the plane containing dipole moment and electric field. According to right hand thumb rule, the SI unit of torque is Newton meter. In case of angle 0, torque is 0. In case of angle 90, torque is PE, that is maximum value. In case of angle 180, torque is 0. Work done by electric dipole in uniform electric field. If a dipole is rotated in uniform electric field, then the work done is equal to dW is equal to torque d theta is equal to PE sin theta d theta. Therefore, work is equal to integration of PE sin theta d theta from theta 1 to theta 2. It gives work is equal to PE cos theta 1 minus cos theta 2. If the potential energy is arbitrarily taken 0, then the dipole is at 90 degree. Then PE is rotating on the dipole and including it an angle theta. Then in case of this, potential energy U is equal to minus PE cos theta. Special cases, when theta is equal to 0 degree, U is equal to minus PE, stable equilibrium. When theta is equal to 90 degree, U is equal to 0. And third case, if theta is equal to 180, U is equal to PE, unstable equilibrium. Thank you for watching Physics for You. Please like and subscribe and share.